Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning. Okay, we begin with the schedule. This semester, the course being set on Monday, 9 till 12, 9 a.m. till 12 p.m. So 3-hour course. Basically, we are going to have a lecture for 40 minutes or more, 40 minutes to 50 minutes, and then we have a short break for 15 minutes probably, and we will continue with the for our second part of the lecture, and then maybe the last hour we will use it for problem solving, tutorials, and as well as our as I said, we are going to have lab session. Even though the course is 3+0, there's no specific lab, but in the curriculum we are planning to have a simulation using a software called GasTurb. In terms of the methods of teaching delivery, we will have an online live session, something similar like this. I think you are quite familiar with the online session. And we also have a recorded video, the video coming from my previous lecture that I'm going to use it again. Some of it going to be updated and some of it is quite similar, and we will show the recorded video during our online live session, right? And then we will have a Q&A based on the recorded video. Okay, that is the schedule. Okay, in terms of the introduction to the course, maybe some of you have already looked at Putra Blast that I have already uploaded a series of videos, especially that going to be covered today, right? And with regard to the synopsis of this particular course, Air Breathing Engine, okay, this particular course covers the detailed design of an air breathing engine, right? This is a continuation of propulsion subject 3513 subject, 3513 subject that you have already taken in your third year, and is the prerequisite is that particular subject, propulsion subject, meaning that if you still haven't got the chance to take the subject, or you fail the subject, you won't be able to take this course. But I believe if you have already registered, meaning that you have already passed the course. So why I say so is that the knowledge, the prior knowledge, the basic fundamental of propulsion, especially on the aircraft propulsion, is needed in order for you to continue for this particular course, right? So what's being covered in this particular subject? So we are going to look into the components of air breathing engine. So we are not going to look into rocket propulsion. We are going to just focus on aircraft propulsion. So the main three components of air breathing engine, of course, we have the inlet, we have the compressor, we have combustion chamber, we have turbine, and the nozzle. However, for this particular course, we are going to focus more on the three core components, which is the compressor, and then the combustion chamber, and the turbine, right? So we are not going to look into detailed design of the inlet as well as the nozzle, right? And we are going to look into the design parameters in terms of when the gas turbine engine designer, what are the parameters that they look for in terms of to set the performance of the engine, to set the parameters in terms of the limitation, okay? And then we will also look at the energy transfer and fuel system, right? At the same time, we will also look into the future development of the air breathing engine, okay? So some issues in terms of course, typical emission problems, noise problem, even though we have touched a little bit in the propulsion subject, but in this particular course, we will look into the current issues. What are the new development? Where does the design of the air breathing engine leads to, and how does it contribute to the sustainable development goals by United Nations. And then in terms of the evaluation, of course, as usual, we have the coursework that covers 60%, and the final exam is covered by 40%. All right. For the next few slides, I will highlight the topic. Right? We have 10 topics need to be covered in the syllabus. However, depending on the progress of the classes, probably we will try to cover most of it, maybe not all, in terms of the topics. So the first one, we will look into the introduction to air breathing engine. It's just an overview, like a revision on what is air breathing engine all about. We will look into the subtopics such as open cycle, single shaft, and twin shaft arrangements. We will also look at multi-spool arrangements, closed cycles, because you have open cycle and then we have closed cycle. We want to see the variety of the different type of cycle for air breathing engine. And then we focus on aircraft propulsion. Of course, there are industrial application as well. Air breathing engine is not just being used for aircraft, it is also being used for power generation. And finally, we will also look at the gas turbine design procedure. So hopefully by today, after this particular introduction section, I'll try to go through topic number 1, so that we will have ample time to cover all the topics that being arranged for this particular course. And in the following weeks, we will look into topic 2. The title is shaft power cycle. We will look at ideal cycles, right? You have already been introduced the Brayton cycle, jet engine cycles in your propulsion subject. And this is just a continuation. We will look at shaft power cycles, and we will also focus on the methods of accounting for component losses, right? And then look into the design point performance calculations, and we will also analyze the performance of practical cycles, comparative performance, where we look into combined cycles and cogeneration scheme, different arrangement, and finally closed cycle for gas turbines. So topic 2, maybe we need to use up roughly about 2 to 3 weeks, because we have some examples to look into, and it depends on the performance of the class. If everybody are at the same rate of performance, maybe we can finish within 2 weeks. Okay. And the next topic is a gas turbine cycle for aircraft propulsion. This is where you look into the criteria of performance, where we touch a little bit on the intake and propelling nozzle efficiency. Not that detailed. We just touch base on the two other important component, the intake and the nozzle. And we will look into simple turbojet cycle, as well as turbofan engine, turboprop engine, and how thrust being augmented, augmentation of thrust in the gas turbine cycle for aircraft propulsion, right? Going into topic number 4. Number 4 is the topic talking on centrifugal compressors. As you all know that we have two type of popular compressors. One is centrifugal, the other one is axial compressor. So we will focus on the principle of operation, even though you have done this in the propulsion subject, but this is to look into more design approach, how the centrifugal compressor being designed. We will focus on the work done and pressurize, how the diffuser play a role in the performance of the centrifugal compressor, the effect of compressibility, and non-dimensional quantities for plotting compressor, and finally a computerized design procedure. This is where we are going to use the software called GasTurb. So I'll explain a little bit more further in terms of the software that we are going to use. And going into topic number 5, so after centrifugal flow compressor, we will discuss the topic on axial flow compressor, right? We will look into the basic operation. We will look into the elementary theory, factors affecting stage pressure ratio, blockage in the compressor annulus, degree of reaction, three-dimensional flow, and the design process. Even though there are so many subtopics, I believe we are going to cover each topic number 4 and topic number 5 within 2 hours of lecture each. Topic number 4, 2 hours. Topic number 5, another 2 hours. Upon completing the compressor topics, we are going to go into the combustion system, where we'll look into the operational requirements. So types of combustion system, of course, there are 3 main popular combustion chamber types. And then we look at the important factors affecting combustor design. What are the things that the air breathing engine designer look for when they want to decide whether it's going to be a can type, or it is going to be an annular type, or a combination of can annular combustor design. So we will also look into the combustion process. Some equations will be involved in terms of the combustion process, combustion chamber performance, and of course some practical problems before we look into the final stage, the gas turbine emissions. So it is just a continuation, the one that you learn in propulsion subject. This is a continuation where we look at the aspect of design, rather than just at the surface. That is topic number 6. Okay, number 7, we will look into the flow turbine, axial and radial flow. Okay, there are 2 types of turbine. We will look at the elementary theory of axial flow turbine, the vortex theory. I believe you have done the experiment. If you have took laboratory 3, aerospace laboratory 3, the turbine, different turbine arrangement, okay, estimation of blade profile, pitch and chord, stage performance, overall turbine performance, and we will also look into the aspect of cool turbine, whether it is being having film cooling, impingement cooling, transpiration cooling. There are so many types of cooling being used to protect the turbine. So we will look into more detail. And finally, the radial flow turbine will also being discussed in this particular topic. That will be topic number 7. And going into topic number 8, this is also a topic that being used by gas turbine engine designer to predict the performance of simple gas turbine. This is where we are going to heavily use the software called GasTurb. We will look into the component characteristic. There are off design and in design or on design operation. So, but we are going to focus off design operation of a single shaft gas turbine. We will look into equilibrium, running of gas generator, the operation of free turbine engine, operation of jet engine, and we will also look into the methods of displacing the equilibrium running line, and finally incorporation of variable pressure losses. So looking at the performance of previous batches, we hardly touch topic number 8 because of the time constraint, but hopefully this particular semester, with the availability of the software, we can now run the simulation, a prediction of performance of a simple gas turbine. And to continue that, topic 9, if time permits, if we have ample time, even though we have only 10 topics, but not all topics being covered within a week, there are cases that we need more than 3 hours of lecture. So that's why we take 3 weeks or 2 weeks to cover each topic. And we will look into the components matching if we have ample time. In terms of the conservation of mass, compressor work, turbine compressor energy balance, exhaust nozzle, operating line, general matching procedure, and the transient operation. So it depends whether we have sufficient time to cover this particular topic in our semester. And finally, the last topic, topic 10, environmental considerations. So even though this is the last topic, but I'll try to arrange an invited speaker to cover the environmental considerations. If the speaker is available, we will have it probably before week 7, right? So that we can cover topic 10, environmental considerations. We will look into the air pollution issues, the current aircraft emission standards, stationary gas turbine engine emission standards, the NOx formation, solution on emission reduction, aircraft gas turbine engine and stationary gas turbine engine, both the aircraft propulsion as well as the power generation application. And of course, finally, the noise standards and noise reduction activities. So that is a topic number 10. Even though it is a topic 10, we may cover it quite early. So depending on the flow of the course that we are going to do this semester, and depending on the situation of COVID-19, probably it's best to have it face to face. And but for the meantime, all of our classes up till week 7 going to be use online platform. After week 7, we are going to have face to face session. So that's why I would like to know whether you are in Selangor, within Serdang, or you are in other places, Negeri Sembilan, Melaka, and some of you are still in your home country. So you have to, if you plan to take this particular course, make sure you make arrangement to be here by week 8. So that's why I would like to give early indication that we are going to have a face-to-face session after on week 8 onwards. In terms of the summary, so just to summarize what we have already looked into just now. So this course covers the detailed design of an air breathing engine. Even though we have already learned or been introduced aspect of aircraft propulsion in propulsion subject, but in this particular course, it is an elective course, so it is a continuation advanced aircraft propulsion subject. And then we, as being highlighted, we are going to discuss on the components in air breathing engine, namely the compressor, combustion chamber, and the turbine, component functions, the design parameters, energy transfer and fuel systems, and also looking into the aspect of issues on future development of air breathing engines. Okay, that's what being summarized in this particular course. All right, going into the learning outcomes. Of course, you are already familiar with learning outcomes. We introduce learning outcome each time when we start the course, right? For this particular subject, we have 4 course outcome, right? The first 2 being displayed here, right? And then on over here, we have the program outcomes that being assigned to be addressed in this particular subject, right? In terms of the program outcome, before we go to the course outcome, the course objective, so this subject need to address the program outcome number 1, where it It is about knowledge, where you're going to apply knowledge of mathematics, science, engineering fundamentals, and engineering specialization to the solution of complex engineering problems, right? And then program outcome number 2, we are going to identify, formulate research literature and analyze complex engineering problems, reaching substantiated conclusions using first principles of mathematics, natural sciences, and engineering sciences, right? And then we have program outcome number 5, which look into the investigate ability on complex problems using research-based knowledge and research methods, including design of experiment, analysis and interpretation of data, and synthesis of information to provide valid conclusion. That's why PO5 is when it is being addressed, assigned to this particular course, we need to do some analysis using the software. So of course we are not going to do experiment, but design of experiments and analysis that we are going to use typical software. And then finally, PO7, you should be able to apply reasoning informed by contextual knowledge to assess societal, health, safety, legal and cultural issues, and the consequent responsibilities relevant to the professional engineering practice. All right, so those are the 4 program outcome, PO1, 2, 5, and 7. But you do not have to worry about those program outcome because it's being mapped to the course outcome or course objective, right? What you need to worry is the how do you address the course outcome. The first course outcome is you need to be able to investigate the operating principles and application of air breathing engines. This is being mapped to PO1, meaning that if you can do investigation on the operating principles, you can understand the application of air breathing engine, how does it work, you already addressing PO1. Okay, that's how it works. And then the second course outcome is you need to be able to evaluate the gas turbine cycle for aircraft propulsion. So you are going to be exposed to simple example, not simple, complex example for gas turbine propulsion, right? And then it is being mapped to PO2. So if you manage to do this course outcome number 1 and course outcome number 2, you are going to be able to achieve program outcome 1 and program outcome number 2. To continue, we have course outcome number 3, predict performances of air breathing engine, that being mapped to PO5. This is where we use the software gas turb. And finally, propose solution for environmental effects. You are going to cover this in an assignment or in a test that is being mapped to PO7. So it is a mapping 1-to-1 to make monitoring easy, so that you when you cover all course outcome CO1 until CO4, course outcome number 1, 2, 3, and 4, you are addressing the program outcome at the same time. All right. Okay, in terms of the assessment, we are going to have assignment, probably 1 or 2 assignment that will contribute to 20% of the coursework. And we are going to conduct test 1. Most likely it's going to be in week 5. This will be online, test 1. And test 2, in week 10, most likely it's going to be face-to-face, because the faculty allow us to conduct face-to-face after week number 8 onwards. It's going to be 20%, and final exam going to be face-to-face 40%. So it depends on the situation. If the university decided that we are going to do all online for this semester because of the pandemic situation, then we can change the plan. And this is a plan. The plan, because I'm just following what the university are asking us to do. So the first 7 weeks is online, and then the second 7 week going to be we are allowed to do face to face. So for this particular course, we plan to have online session first for the first 7 week, and then the next 7 week going to be face to face, because we are going to use the software at the design lab. Alright, so that is the sharing session for today.